Hello, this is Sharan. This is regarding icp8 video recording. The assignment challenge is to use the given pre-given dataset, that is a managed dataset, and in order to build the various encoders, the given architecture is supposed to be changed with 2 layers at minimum in the encoder and 2 layers at minimum at the decoder. So there are 2 variations of the 2 approaches that I have done as part of this assignment. So the overview of my change is that I've added 3 layers of 2-dimensional convolution layer, which is of 32 filters, 64 filters, 128 filters. And I've also changed the kernel size of the filters to 2 into 2 rather than 3 into 3. And I also changed the stride as 1 instead of value 2. 1 is the minimum possible value, and also added 3 batch normalization layers. And the decoder changes and is the same thing that I did symmetric with the encoder changes. So here are some questions that I try to answer. Why change in the kernel size and the stride change? I have reduced the kernel size on the stride change because the lower level of filters, the lower dimensional filters, which from 3 to 3 and 2 to 2 is changed, will give me more information or will leave more features in after doing the convolution. So it will give me more accuracy, or it might give me more performance. On those lines, I've reduced the kernel size. And the other contributions I made is I've also fixed the code to capture the validation accuracy and the training accuracy. I've also passed this to plot the images as a very fixable, flexible plotting curve for both accuracy and the validations. So let me go ahead and run these approaches. I'm just doing run all. As we can see, the layers are updated as with 32 filters, 64 filters, and 128 filters. And the same is what is 128 filters, 64 filters, and 32 filters. And as we can see, the training is currently happening here. And before the training finishes here, let me go ahead and explain the second version of my approach. So the rest of the architecture remained framed the approach 1, but then the activation function, which is ReLU, has now changed to ELU. ELU is nothing but exponential linear unit. This is another variation or a strong counterpart to ReLU in terms of activation function. So I've used this as my new activation function in the convolution neural network. As we can see, the activation here is ELU, not rectified exponential linear unit. So using this, I've tried to measure the validation performance and the accuracy, which is pretty much closer to the same thing, which is about 79.87 in approach 1 and 79.37 in approach 2. So that's not a significant difference. So I could infer the latent space in the variational encoders. It also holds the random sampling and standard deviation and the mean values in the latent space. So the latent space, despite increasing the depth of the neural network, is able to capture only 80%, and still we could see that translational loss from encoder to decoder stayed about 20% in terms of accuracy. So that's because of the latent features is what I would infer from the testing. So here are some few quick graphs with accuracy versus epoch and loss versus epoch. As we can see, we have not seen much change in the training curve, and the validation curve was slightly increased right from the starting, but it has significantly stayed there with only a limited number of changes on around these areas. So talking of this, let me go ahead and run this as well. So as we can see, we have finished the training of this first neural network, which is based on railway activation function, uh, and the 12 layers of neural networks that we have introduced, that is for 32 filters, 64 filters, and 128 filters. And as we can see, the accuracy levels is pretty much the same across both the models. It is about 79.39, which keeps changing by some decimals at each run. But the visual representation of this is quite good in terms of in ELU activation function, exponential activation function. That's because the activation function shoots up the say activation values when there is a significant increase in the gradient propagations. So that's where we could see these clustered environments looking more visually appealing in terms of ELU activation function. So that's where it stands, and as we can see from this run, it is currently still running at the epoch 37, at the epoch 27. Thank you.